You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
2 West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
Yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady
And Levi.
and Brady too. We're the 3 members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed.
That was the one thing.
Which makes it a rap.
Yes, all raps have one rhyme.
We'll see you on 2 West.
Yes. 2 West.
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because moths are the
disgusting gray moths.
Yes, those gray moths that you hear, they're
Yeah.
like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all. Whoa! Look who's here. It's Levi and me. I used that correctly. I didn't say Levi and I. I usually mess that up.
I had a friend, I think I mentioned this to you, who said that. Yeah, and then he had the friend change. You know, when you change your friends.
Oh, right. And so you were kind of... You're out of there.
Yeah.
Yeah, you gotta watch out. You shouldn't go for friends that are gonna do the friend change.
Yeah, cauterized right off. I'm gonna give him markers.
Cauterize? Is that what you said?
Yeah.
Oh. Hey there, Brady, Levi, and chat. How's it going? Hey there, Slayer Dart.
Hey, Dart.
I don't speak for myself or Levi, but I do speak for the chat. We're all doing well. Levi, how are
Chat's
we
doing well. I implemented the Oxford comma for your gratification.
That's very true.
Oh, I feel very gratified.
I also feel extremely gratified. Yeah. That Oxford comma is, I mean, I could look at Oxford commas for days. Just lots of lists.
So many lists.
Not one long list, because then there'd only be one Oxford comma, but just... Oh, it's Hono. Hello, Hono. How are you? Are you doing well, Hono? How's your back? I know your back's been hurting. Is your back okay?
You gotta do your back exercises.
You gotta do
the cat
stretches.
and the cow, you know?
Yeah.
The cat and the cow? No. Cat, cow, and cat. Cow, cat. Cow.
Are we rowing?
Cat. Yes.
Yeah, we're rowing. Look at that. Very good. Anyway, I hope your back's fine, Hono.
Yeah.
I don't think you had any problem. I tried to do some studying today, but couldn't get much done. Not an actual student per se, so no biggie, as we had a heat wave in London today. That's probably the heat wave that left New York recently.
Yeah.
It probably just
Hopped on a flight and
flew across
Yeah.
across the pond real quick.
Took the red eye.
Yeah, must have. Hey, are those Milanos?
Yeah.
Oh. Can I not have one? Thanks, man. You guys got any questions? We're going to talk trig functions. Do I have a question for you? No.
Yeah, you're gonna talk.
The Milanos? Is that why you... Yeah. Yeah, Slayer Darth. It's better to do math when you're extremely sweaty. So I'm actually not sure why you couldn't get studying done, because you were very Oh, that T's got a little tooth on it.
Yeah.
I think school exams in France were delayed because of the extreme heat. Yeah, that sounds about right. They always delay exams in France because of extreme heat. So, Slayer Darth.
That's terrible.
What do you think about this Boris Johnson business? Are you stoked? Are you not stoked? Do you feel absolutely nothing?
You know who Boris Johnson is?
I hope, yeah, I believe Slayer Darth is going to know.
Slayer Darth has no idea who Boris Johnson is.
Oh, Slayer Darth knows who Boris Johnson is. Do you know who Boris Johnson is?
Yeah, he's the Trump-looking dude.
Yes. You know what just happened?
He is gonna pull off Brexit.
Yeah, because he is now the Prime Minister of London. Of England.
Marry Victoria?
Of England. Yeah, that's exactly right. Yeah. He's a poor clone of Trump. He is rather Trumpian. Yeah, he is. His hair is intentionally a mop. It's a weird mess for a man
to
his
clean
age.
up the Brexit mess.
Yes, he used his hair. That's very good. That's extremely good.
Okay, why don't you do this?
I think I will. I think I will.
That's what I should have done. I should have gone like that and then
Oh, yes.
And then a little bit of this.
A little
and
bit of this thing in my life. Oh, that's got a vertical shift right there.
Oh yeah.
I
It's
go
actually
on and
the
on.
diagonal rotation that you do on the.
I suppose you're right. I could go on and on about Johnson. Oh, go on. Now, okay. But he used to belong to a private members club at Oxford University called the Bullingdon Club. Bullingdon Club. And what happened at said club?
Bullingdon. That's such an English.
It really
British
is.
English word. Bullingdon.
Bullingdon. Yes, it is. Yeah, let's start. Let's start, huh? Yeah, let's do that.
I'm gonna go sit down, bro.
Very good. We're going to graph y is equal to sine of x. All right.
Now, what goes into sine is an angle.
You take sines of angle measures, and they essentially cause massive property damage. Yeah, that sounds like what a private members club at Oxford University would do. To their own headquarters, or just they went out and caused debauchery around the neighborhood? Which of those? From what I read, all they did was commit acts of vandalism.
Ah, got it. Okay. That doesn't surprise me oh god. That doesn't surprise me in the least or the slightest.
The least, yes. Okay. Yeah, so we take a sine of an angle and it spits out a ratio measure of the actual sine. This graph makes a lot more sense if you are familiar with the unit circle. So I am going to draw that right now for your edification. Unit circle. Unit circle. Call it the unit circle because it has a radius of 1 unit. We graph it on the y-x, xy coordinate plane, and it has a radius of 1 unit, so this right here would be 1, 0. This right here would be -1, 0. This right here would be 0, -1. And this right here would be 0, 1. All right? Anyway, exactly. The unit circle allows us to find the sines and cosines of any angle from 0 to 360. Here's how it works. An angle, theta, we'll put it right here. We start angles on the x-axis, the positive x-axis, and they rotate upwards counterclockwise. That's just the convention, what we've always been doing. If I make this a right triangle by just dropping down this right here, let's look a little closer at that triangle. So, for one thing, this right here is theta. That's what we call theta. This hypotenuse, because it is the radius of the circle, and this is the unit circle, the hypotenuse is 1. Yes. Very good. All right. Now I'm gonna call this A. I'm gonna call this B for right now. Okay. If I were to take the sine of theta and the cosine of theta, let's see what we're gonna get. Sine of theta would be opposite over hypotenuse, which is going to be a over 1. It's been a while since I've tackled trigonometry. Exactly. And we've been worried about your trigonometry, Slayer Darth, which is why we're bringing it back. Get low. Is that you?
Yeah.
Very good. All right. And then the the cosine of theta will be b over 1. So something fun just happened. Since our hypotenuse is 1, we're taking both of these side lengths over 1. Which means that over 1 doesn't really do anything for you, so I can just erase those. So what that means is that our A side is the value sine theta?
Why not 3, my lord?
It might be 3.
Why not then?
Well, because not today.
Yes, my lord.
So this side here actually is the value of sine theta, and this side here is actually the value of cosine of theta. Okay. Okay.
Hi, Matthew.
Ring Matthews, hello. Hello, Ring Matthews. One Ring Matthews to rule them all. Okay, so I'm just going to throw that in here. Bam. That is sine theta. Can you guys see that? Yeah. And this right here is cosine of theta. All right. I'm going to be doing radians here. Hey, look, there's a great community here, Levi. Slayer Darth is asking Ring Matthews how it's going.
I heard.
Yeah, that's very exciting. We're going to use radians here. Okay, so just a little primer. I don't know why some people say primer and primer, but the deal with radians.
Isn't it the premiere in Britain?
Yeah, it's the premiere.
Okay.
Yeah. Radians are another way to measure angles. We've known degrees for a very long time, but 360 is made up. We just decided to call a full circle 360. This is a much more natural way of measuring circles. So let's say you have a circle with radius 10. If that is the case, then your diameter is 20. The circumference of a circle is either pi times diameter or 2 pi r. You can use either. And in this case, if we do, let's just say pi times diameter, that's 20 times pi. 20 pi. The distance around the circle here is 20 pi. Let's say I give you guys a right angle, and then I say, what is the distance from here to here? So just along this arc length, from the beginning to up there. That distance right there. I don't know how many of you can actually answer my questions. I don't know if I should just keep going, but if anyone, such as Ring Matthews or Slayer Darth, is here, which I know you are, that distance right there. See if you can figure out that distance. If this is 90 degrees, and the circumference of the circle is 20 pi. I'm going to make another line here. That is the distance I want you to find. And if it ends up being in terms of pi, just leave it in terms of pi. Levi says it's 3.
3, my lord.
Is anyone going to disagree with Levi? Someone, 5 pi. Yes, Ring Matthews, thank you. It is 1/4 of the circle. That's 90 is 1/4 of 360, so this sector is 1/4 of the circle. So this right here is 1/4 of the overall circumference. You'll be lurking. That's fine, Slayer Darth. Lurk away. Sir lurks a lot. He's one of Arthur's cabinet members. Fantastic. All right. So 20 pi is around 62.8. So you're going to walk around the circle. You're going to walk 62.8. Busting out my Serge Lang PDF. Sergey Lang PDF. I'm not sure if I know what that is, but that's good. Maybe surgery language PDF? I doubt it, though. That wouldn't really make sense. Okay. Remember, ask us questions. We are here for you. So you can walk along the outside of the circle, and you're going to cover some kind of a distance. In this case, we covered 5 pi, which is around 15-ish. That's how far we walked. Let's think about this in a slightly different context. Okay. I'm going to finish this circle again. I'm going to give us a different radius. A different radius is going to be, he was a maths professor at Yale and Columbia. Ah, very good. I love maths. I love that. It makes sense to call it maths, mathematics. But anyway, if this is 3 units, this radius is 3, probably a unit looks like that. If you start walking along the radius, along the circumference, this right here looks like it's about 1 unit. This one here looks like it's about the 2nd unit. And this one here looks like you've walked around 3 units. I should probably put 1 right here. So something special just happened. You just walked a distance around the circle that was the same as your radius. Here are a variety of textbooks for teaching algebra to high school students. Hey, very good. Very good. Break that out. Bust it out. Start reading it. Don't breathe until you're done. Okay? This distance here is very special. We just walked the same length as the radius. The angle that makes that happen, so I'll draw right here. It's around 57 degrees. Any circle you could draw. If you want to go one radius distance around your circumference, that'll always happen around 57 degrees. Not exactly 57, but decimal. That right there is 1 radian. That is how we define a radian. This angle is the angle you need to open up so that your arc length is the same distance as your radius. All right? So there's this equation, equals S over R. Well, they're just going to keep going here. Okay, so the total number of radians in a circle is the same question, how many radiuses fit around a circle? If pi diameters fit around a circle, then because the radius is half as small, you're going to need 2 pi radiuses to fit around the circle. So a full circle is 2 pi. So just some basic angles here. This right here is still 0. If we go around halfway, we get to pi radians. So that is this angle right here. That's pi radians. There you go. If you go around to the rest of this, you get 2 pi. That's the end of your circle. But in between, we got 90 degrees. That's half of this. So this is pi over 2. This one here is 3 pi over 2. This right here, 45 degrees, is going to be, I should just probably write it right better. 45 degrees is half of pi over 2. So this is pi over 4. So you see where this is going. We're going from 0 to 2 pi with nice little fractions of pi. Okay? This is all going to come together in one massive explosion of goodness, and there will be candy and chocolate and a pizza party and lots of confetti. So let's think about the sine value here. The sine value is the y coordinate, this y distance, of this point. This point we call the terminal point, and it's got the coordinates cosine theta, comma sine theta. Because its location along the x-axis is this x distance right here, which is cosine theta. Its location on the y-axis is sine of theta. That's its height. So that's the coordinates right there, the terminal point. So if you just watch what the terminal point does, you will see the sine and cosine from its coordinates of the angle that is opening up to that terminal point. Okay? There are a variety of animations that are really good. Levi, I wonder if we could... Oh, we can absolutely pull up an animation. Oh, man.
You want to do that now?
Oh, absolutely. I love this animation. And you're going to love it too. And everyone's going to love it. Let's get... Here we go. This is going to be excellent. I never think we can pull up a video, but we can just do screen capture and then it's going to be fine. Okay. Unit, circle, animation. And let's see, is this one going to be good? No, not that one. Let's see. I want to get some animations here. This will probably be pretty good. Yeah, okay, that's what we're going to do. Can I? Oh, I can. That's fantastic. Okay. And then I'm going to pull this up. Oh, excellent. Levi, we've just entered the new age of nerdish.
Yeah?
Yes.
Ooh, that's fun.
Yes, it is. It's very fun. Okay. Let me get more of this. All right. Let me shrink it now. Let's see what's happening. So our angle is opening up. Our angle is opening up to 360 and then just starting over again. And our sine value, oh, you know what? I got to match this. I want it to be the same. There we go. Okay. All right. I want the height to be exactly the same thing. You'll see what I'm talking about in a sec. Okay. So if you see the y coordinate of our terminal point as it's going around, that is the sine value. So as we rotate, the sine value increases, gets to 0, then decreases to -1, and then increases to 0, increases up to +1, decreases down to 0, decreases to -1, increases back to 0. It's periodic. That's why these are periodic functions. It'll start redrawing it again. Angles don't really end at 360. They can keep going. So this thing here is programmed to stop at, what is that, 720. But the sine wave continues on and on forever because you can just keep rotating. So that is why the sine curve looks the way it does. It's because we're just tracking that y coordinate of that point. Let's get just one more cycle here where it pops up on the screen. Let's go. There we go. Yes, that's what's happening right there. Excellent. We're all doing extremely well because there are no questions. So therefore, you're all just sitting there with your mouths open going, oh my God, this is all making sense. The cosine is the x-coordinate. All right, the x-coordinate is a little trickier on a graph like this. I got to go over here. Here we are. Okay. Because they're taking something that's an x-coordinate and then they're mapping it to become a y-coordinate on that graph. Sine should hopefully get rid of itself. Come on, sine. Okay, sine is not going to get rid of itself. Okay, so we're going to see this right here. So you see cosine is just scooting back and forth along the x-axis, and they're mapping that distance on this graph. So cosine and sine pretty much do the same thing. They just start at different places because they're oscillating between -1 and +1 as you rotate around a circle. The difference here is that cosine starts at +1. When you're at 0, when you're at the origin, or at least when you have an x value of 0, which means an angle value of 0, your cosine is already +1, which is why you see that peak happening directly on the y-axis. Whereas sine starts at the origin because the sine of 0 degrees is 0. Okay, that's what those functions look like, and that's why. So now we're going to talk about moving them around. There's some animations I can show you that'll blow your mind.
Yeah?
Yeah, but not now.
Okay.
Yeah. You just don't need it. Why is it spinning? I just randomly came back. Oh, Hono. Hono, you good with trig functions? The sine function, the cosine function? If not, I will pull that up again. Because it's rather beautiful to watch. Do you want me to pull it back up again? I mean, I think you do because you're asking why it's spinning. No, I get trig functions. Okay, the reason why it's spinning, then just real quick, it's showing you as you rotate around the circle, what your, let me make the sine one. I always do that. Let's go over to this. The blue line is the sine function. The sine function maps out what the y-coordinate is of the unit circle's terminal point. So you can see how that distance, that the y distance of that terminal point as it's revolving, matches the sine function. That's where sine function and cosine function come from. They're periodic graphs that are modeled based off of rotating around a circle and just looking at the x-coordinate, which is cosine, or just looking at the y-coordinate, which is sine. There's a better animation I think I can show you. Desmos. Here we go. This is a good one. All right. So this right here is mapping out the sine function. It's just that y-coordinate is what creates the sine function. One of the hard parts about this is that your x-axis represents the angle that you've opened up on the circle. As your angle opens, we move to the right along the x-axis. And then you get your sine value as the y-coordinate. Hono, does that make sense? Does that make sense, Hono? Let us know. We need you, Hono. You're our only hope. All right, Hono, I'm going to assume that you get it. I'm going to assume that you get it. So I'm going to put on cosine. There we go. That's why cosine looks the way it does. It's mapping out that x distance. And then if you really want to see something cool, I'm just going to pull it up because it's awesome.
Yep.
Leave page. Let's see. GIFs. Yes. Which one do I want? Oh, I want this one right here. Okay. Levi, come check this out.
Just on the screen, or should
Yeah, just on the screen. It's doing both sine and cosine at the same time.
Oh, that's fun.
I just love how it has to curve cosine around to make it on a horizontal graph.
That is fun.
Isn't that fun?
Yeah.
You guys just want me to make this really big and then just have that up for the rest of the day? So that's just nerdish. It's just that today. Levi and I can do that. Just think of sine as Brady and cosine as Levi. And then, you know, that's pretty much it.
I'm cosine?
Yeah.
Okay.
I'm sine. Is that cool?
Yeah.
Okay. Anyway. Fun's over. Now we're getting to the real stuff. No, I'm just kidding. It's just going to keep getting more and more fun. Progressively more and fun.
Do you want, so we have like 12 robot dancer questions, which we should probably just do together as once you finish this. How much more you got? You got 10 now?
No, I'm not going to do 10.
Okay. Just,
Yeah.
So you're done?
Yeah, you know what? I haven't talked about transformations, but like just the basis of where the functions come from. That's what I just sort of did.
Yeah, it'd probably take a long time.
Even though that's like what they ask about is transformations.
Yeah. We can talk about it tomorrow.
Yeah, we could. Yeah. Yeah, we can do some what's it called? Robot questions. All right. Discord. Okay, so Robot asked some questions last Saturday. Oh, interesting. Okay. So, Levi, what do you remember us doing?
You can see that when he...
Oh, I see. Okay. Is Robot a boy or a girl?
We can't quite comprehend.
Oh, okay, because it's a robot.
Yeah.
Okay.
Wow, I set up too fast. There's the sentence combo question. Yeah, that one.
Big time.
What did robot say underneath that question?
I will tell you in just a second.
Okay, so we're doing some robot dancer questions because he put some questions in the chat on Saturday, but he's not here. So we're happy to, intermittently do your questions. So if you have questions, ask us. We will do them. We can pull up any test you want as long as it's online somewhere, or you can feasibly email it to us or something.
You can fax it to us.
Ideally, fax it.
Ideally, if you have like a gasoline-powered fax machine, you should use that.
Yeah.
Yeah, you pull the cord.
Pull out that old printing press you have and print it.
Yeah. If you have like a Gutenberg press, that would probably be the best way.
Yeah.
I'm thinking right now about going straight from to like the fax machine noise, when you fax something, like the old dial-up noise, and the combination of sounds is just more than someone could bear.
Like that?
Yeah, that's what I was thinking about.
Got it.
Yeah, it's very fun.
I see how you're thinking about it.
All right, I'm going to just erase this. You can go ahead.
Okay. So, Robot Dancer, this is your first question from Saturday when you posted this. This is a sentence combo question. What you wrote after this, where you posted it in the Discord, you said something about dependent clauses and independent clauses separating with comma fanboys or something. That's not what these questions are about. They almost never try to get you on that. Number 5, the answer is A, but I don't know how. So they is a dependent clause, and comma fanboys separates two independent clauses. Okay, so new players in Antarctic affairs such as China are oil-poor states, and so they, yeah, I see what you're saying there. These questions they are not asking about punctuation. They're asking about sentence combination, and it's more about context and staying in line with the general thrust and content of the passage, not punctuation and almost never grammar. So I wouldn't worry about that. Let's skip A for now. And I don't have a ton of context for this passage.
Wait, Ring, the first thing is not a dependent clause. The first thing is an independent clause.
No, so Ring has just copied and pasted what Robot Dancer said in the Discord.
Oh, very good.
Yeah.
Okay.
So you're saying you don't like how it says "and so." This is Robot. And so, just don't worry about it. It's not too important for this type of question. It's about the content of the passage, not the grammar, not the punctuation. So it's not nuts and bolts stuff. Okay. These questions require you to know exactly the idea of the passage as a whole, where the passage wants us to go. We need to stay on topic. And that means that our subjects need to be on topic. The idea of our sentence, passive voice can come into play sometimes, but sometimes they can be the right answer. Because the most important thing is effectively combining the sentences. Now, these are pretty vaguely worded questions, because what does it mean to be effective? In this case, it's being effective towards the purpose of the passage as a whole. what I mean by that is, let's take into account what this passage is talking about. I think I have like 4 lines of stuff. I think it's talking about the Antarctica and oil, like the oil underground in somewhere in the Antarctic or something like that. So it's about Antarctica, I'm hoping. Otherwise, I'm totally off, and then it is what it is. Answer choice A. And it doesn't matter what the original sentences are. That doesn't matter at all. So we have new players in Antarctic affairs such as China are oil-poor states, and so they view Antarctica's mineral resources as one solution to their increasing oil demands. Okay, so this is not really talking about China, right? We don't care about China in this passage. We care about the Antarctic, and we care about the mineral deposits. Maybe I'm hoping that's what we care about. And that the way A is set up, it's talking about new players generally, and it's saying that they see the mineral deposits in Antarctica as a potential solution for solving their oil demands. Whereas B is new players in Antarctic affairs such as China are oil-poor states. So that is its own independent clause. We don't care that new players in the Antarctic are oil-poor. Does that make sense? We get that information from A, but in B we've made that an entire independent clause, and that's not the point of this passage. Then we go on and say, even though they view Antarctica's mineral resources as one solution to their increasing oil demands. That's saying, so they're oil poor even though they see this as a solution. I don't know why you would say that when we're trying to talk about Antarctica and those mineral deposits. Then we have C. New players in Antarctic affairs such as China are oil-poor states. So same problem, viewing Antarctica's mineral resources as the solution to their increasing oil demands. The way this is worded makes it about those new players. We don't care about China. We care about generally people seeing those mineral deposits in Antarctica as a solution for oil demands. That's what we care about. Now, I don't have a ton of stuff to draw from because I only have 4 lines from this passage. I'm assuming that's what it's about. It's not about China. It's not about them being oil poor. We don't care about that. And D, we have new players in Antarctic affairs such as China are oil poor states. So same problem. Despite their view that Antarctica's mineral... So again, that falls with B, C, and D. I'm going to read A again, and let me know if this what I'm saying here doesn't make sense. This is a little bit more wishy-washy than other types of things where it's just, okay, well, you didn't separate these independent clauses correctly. That's not what this question is about. In A, new players in Antarctic affairs such as China are oil-poor states, and so they... Oh, that is the same thing. And so they view Antarctica's mineral deposits as one of their solutions. So that is... By saying and so, that is causal, right? They are oil poor, so, and it moves it away from oil poor. So ignore what I said about that being its own independent clause before. It's that it moves it away from oil poor to, so there's this thing. It is a causal relationship. That's what we want because we want to start moving in the direction of they're seeing the minerals underground in Antarctica as something they can use. That causation is necessary. I think. This was the best I could do with how much information I have. So that's what these are about. It's not about comma fanboys. It's not about DCs and ICs. That's not what these are about. Okay, that was a pretty poor explanation. Let's see something that we have more information for. This looks fun. Just missed. Okay. Do we need these? I don't know yet. All right. This is a math one. Oh, we'll see how this goes. All right, so we have these 2 equations here. Lovely. And we got a bunch of variables, it looks like. In the system of equations above, P and Q are constant. So P and Q are not variables, but you kind of treat them like you have to solve for them still. P and Q are constants. X and Y are therefore variables. If the system has infinitely many solutions, what is the value of P over Q? Ignore P over Q. That's not necessary right now. When they say infinitely many solutions, that means these lines have to be exactly the same thing, right? These are linear functions, right? There's an x, there's a y, there's no powers, there's no radicals, there's nothing weird like that. So they're just linear functions. For 2 linear functions to have infinite solutions, you're not just going to have some random, linear functions that cross here. That is exactly one solution. You're not going to have parallel ones because that has no solutions. You have to have that line, and then you have to have another line right on top of it, right? You're going to have two lines. Hopefully that's clear. So to have these identical lines, that means that in whatever form you have them written, like up there is fine, they have to be exactly the same. So we need to manipulate these equations so that they look the same, and then we can identify what P and Q have to be. Now it looks like they're asking us for what P over Q is. What is P divided by Q? I'm going to say, no, okay. If they're the same, no, I'm not going to go at it that way. We want to make everything in these equations the same, and then we can figure out what P and Q have to be. So how can we make these things the same? I think I'm going to rewrite these down here. So we have Px minus 6y equals 16, and we have Qx plus 9y equals negative 24. Okay, this has to work out. So we don't have to worry about it being weird or anything like that, unless there's an answer that says there are no values of P, or P over Q is undefined, or something like that. That's not the case here. We need to get this part of both of them to look the same, which is actually not too bad. We're going to multiply the top one by negative 3 halves. Now I happen to be able to tell. We need to get from negative 6 to 9 and 16 to negative 24. If you multiply this guy by negative 3 halves, that will leave you with negative 3 halves Px plus 9y equals negative 24. Please check my math if you don't believe me. Now, these are the same, right? Now we'll go to yellow, I guess. These two are the same, so great, we're done there. These two are the same, so we're done there. And now these two have to be the same, right? X is a variable that can change no matter what, but the coefficients have to be the same. That means that Q must equal negative 3 halves P. Please let me know if that doesn't make sense. This is a hard concept. It's sort of a weird twisting of the way you're used to doing math the same all the time, but this is a logical approach. Please let me know if you want help with this so I can go over any part of it. Now, we are asked for what is P over Q, so let's mess with this equation until we get P over Q on one side, everything else on the other. So I'm going to divide both sides by Q, and then I'm going to bring it up here. So dividing by Q means that we get 1 equals negative 3 halves times P over Q. So look, we now have P over Q. Now I'm going to multiply both sides, that was weird, by negative 3 halves. Why did I do it that way? Whatever. And this by negative 3 halves. Nope. I lied. Not negative 3 halves, negative 2/3, because I'm multiplying by the reciprocal to cancel out this negative 3 halves here. So multiply by negative 2/3 on both sides, and we get negative 2/3 equals, that cancels with that, P over Q. Here's our answer. Negative 2/3, so yeah, B, there we go. So I think this type of question is very cool. The way in, because this is not necessarily the most obvious thing to do, is you are dealing with, you're not being asked solve for something, right? You're being said we have infinite solutions. Infinite solutions means, at least for linear functions, or for any function you're going to be dealing with, infinite solutions mean you have the same exact function. So to make it the same exact function, we set them up the same. Now, we have these missing constants, because if we didn't, it would have to be that this is something like 5x and 5x. Or sorry, down here it'd be 5x and 5x. It would have to be the same because they told us infinite solutions. There's no way that this could be a negative 5 here, because then we would never have the other side of the equation line up. So you don't have to worry about that. Once you know the logical approach, it's easy to do these. Exactly, yes. These are finding out coefficients because you're lining up the other side of the problem. I like these problems a lot because they're not just asking you to solve for this. They're saying, okay, we have infinite solutions, or we have no solutions. What does no solutions mean? It means that we have parallel lines. We have the same slope. So actually, let's throw that in there. So I'm going to erase this work, and I'm going to try to figure out what P and Q need to be to have, well, is that just going to, if they have the same slope, they'll just be the same line. the same thing. You can set it up, and then to find slope, right? That's what you want to do. So what I think is the easiest way for most U.S. high school students. Alan, hi. You have questions, no? I didn't realize that was you, Alan. But you said you have questions. Did you just ask some in the Discord? No, not yet. Do you have questions for me or us? For the slope ones, what you got to do is put it in y equals mx plus b form, because then that m is going to be your slope. Whatever your constants are in that coefficient, you can solve from there. Hey, Bird.
Yes.
I'm waiting on Alan, but in the meantime, do you want to do the next robot dancer question?
Yes.
Oh, wait, what?
What do we got?
Here we go. We got this guy. Can you do it?
I want you to do this one.
Really?
Yeah, I'll do that.
Oh, I don't want to do this one.
Fine, I'll do it.
Yeah. This is fun. It's not as boring as it looks.
You're right. It's got a slight little fun trick here. Whoa. All right. If f of 2x, interesting, equals 9x plus 4 for all values of x, what is the value of f of 12? Ooh. Looks like they doubled the x value. That's kind of interesting. Right? That's kind of fun. So, let me write this down. F of 2x is equal to 9x plus 4. All right? So, whatever x is, when you plug something into this function, your function treats that as 2x. It divides whatever that number is by 2 to get x, and then it throws that x in over here. Okay, so if I were to put in f of 10, the function thinks that this is 2x. So if this is 2x, then x would be just 5. We would divide it by 2. And then you'd throw this into your equation. So you have 9 times 5 plus 4. All right, pretty much already did it at this point. But f of 12, the function, because 12 is 2 of x, because 12 is 2x, one single x would be 6. So f of 12, if we look at that like 2x, then the x has to be 6 for that to happen. So then we just do the function, putting 6 in for our x value, giving us, we have 54 plus 4, which is equal to 58. 58, okay? If you double the input, what that means you're going to have to do in order to basically undo that is to halve your eventual x value. I don't like the sound of that. Either way, you have a better way of saying that?
No, I think that's it's a confusing concept. I like the idea of saying that. Yeah, you have. Well, I think you said it. Where this, these are going to be the same thing. So for that to be the same thing, x has to be 6. So that's what you plug in.
Thanks, Levi.
Okay. Do you want to do? Okay, so Alan just asked a question.
Best luck in the world.
Yeah, that was a good hug.
Yeah.
Do you want to do an Alan question?
Is it a math or English question?
It's math.
Oh, fantastic. I have a slight bias.
Yeah.
Yep.
So
I'm addicted. I'm addicted to crystal math.
Oh my gosh.
You like that?
I did, yes.
I also liked it. Very good. Oh, that's good.
Yeah, it's a little blurry.
It's okay.
Can do.
A group of teachers and students will take a bus trip to a museum, and each teacher will lead a group of no more than 4 students. The bus can hold a maximum of 54 teachers and students. If T represents the number of teachers and S represents the number of students, which of the following systems of inequalities best describes the possible numbers of teachers and students who can go on the trip? So there are 2 different restrictions here. Jeez.
Okay.
Oh, gosh.
Do you need to take that?
No, it's a telemarketer. I don't know why my phone's on right now. We'll start with the easier one, which is the bus. All right, the bus can hold a maximum of 54 teachers and students, which means they could have 54, but they can't have anything more than that. So it has to be greater than or equal to 54, okay? So let's look. 54 needs to be greater than equal. Okay, hold on. If you add your students and your teachers together, that needs to be less than or equal to 54, because 54 is the largest that can get. Alan Shoko, he says, wow. Why do you say wow? Good to know for the future. What, the bus thing? Or what's good to know for the future? Anyway, so there's a couple we can eliminate. Actually, there's only one. A is out, because that's saying that the sum of teachers and students has to be greater than or equal to 54. That would break the bus if it's greater than 54. You can't do that, okay? So it's either going to be B, C, or D. So our first one is simple. The sum of the teachers and students needs to be less than or equal to 54. The second part of this, the second part is a little trickier, okay? Each teacher will lead a group of no more than 4 students. No more than 4 students, okay? So let's just imagine that there are 4 students exactly for every teacher. Let's just imagine that, okay? The number of teachers, therefore, need to be, that would be S divided by 4. So here, I'm going to change a different perspective, okay? What's the best way to do this? So 4, okay, number of students is equal to 4 times t. There are 4 students for every teacher. You knew the number of teachers. You'd multiply the number of teachers by 4 to find the number of students. All right, if there's 1 teacher, to find the number of students, you'd want to say 1 teacher times 4 students gives us 4 total students. If you have 2 teachers, that'll give you a total of 8 students. All right, that's where this comes into play. And this is if the number of students is exactly 4 per teacher, okay? Now a couple of these, let's see, these are all solved for t if you look at this inequality. So if I solve this thing for t, I'm going to get t is equal to s over 4. I know we have not yet talked about the inequality. We'll get to that in a second. But that right there eliminates b. b is out of there because it's got 4s. That's not what we want to do. That would cause a lot of teachers because you take the number of students, multiply by 4, and call that the number of teachers, which would be way too many teachers. So it's either going to be C or D. So the most that each teacher could have is 4. Oh, I see what you're saying. You're asking about this. Okay. All right, Alan, I understand what you're saying now. I thought you were saying wow about something else. Oh, anyway, what were we talking about here? The most that a teacher could have is 4 students, which means the teacher could have less than 4 students. That would be okay. So in that case, let's see. The number of teachers could be greater than or equal to s over 4. The number of teachers could be less than or equal to s over 4. Let's imagine the simplest case scenario. There's 1 teacher. We know we can have 4 students. That doesn't help us because C and D, the second equation, second inequality, both work for that. That situation is very easy. 1 teacher, 4 students. I'm putting in my own values here because I find that that is a helpful strategy. And we have 2 things to try. T is less than or equal to s over 4. And t is greater than or equal to s over 4. This situation does not help us. Because if I put in 1 for the teacher and 4 for the students, they're both going to be equal. Which does not... Oh, jeez. Sorry. Oh, gosh.
Heard.
I know. All right, I got to be very, very careful here with my... Okay, so that's going to be yellow. The number of students is 4, so that's going to be this over 4. All right, they're equal. Okay, both of these are going to be equal. 1 is greater than or equal to 4. I didn't mean that. I meant this. I didn't mean this. Levi, I'm a mess right now.
You're a huge mess.
I'm an absolute mess.
So
Okay, so let's imagine a slightly different scenario. All right, we know the teachers can't have more than 4 students, but a teacher could have less than 4 students. A teacher could have 3 students. That'd be okay. 1 teacher, 3 students. Let's see which one of these would make sense in that case. I'm going to keep the 1s there. So in this case, we have 3 students. So this would be 3 over 4. In that case, this would be 3 over 4. Which one of these is correct? 1 is less than or equal to 3/4. No, it is not. It's greater than. 1 is greater than or equal to 3/4. This right here. Therefore, this one has to match. Number of students divided by 4. Teachers need to be greater than that at the very least. They can be greater than that or equal to it, but they can't be less than that. Otherwise, you will not have enough teachers to make this rule make sense. So C is also done, and our answer here is D. Okay? Alan Chocot, does this make sense with your brain, inside your mind? Inside your mind. Do you like this? Would you buy this? Could I package this up in some single-use plastic and offer it to you for a certain amount of money? Is the second part still confusing you? Looks like you got no questions. Yeah, I'm tired. I'm also Brady, but I'm also tired. Doesn't mean I can't be both. All right, I assume that you're good because you're not saying much. Levi, you want to do the next one?
I do.
Very good.
Did that just get said, or got said before?
It's said before.
Okay.
Yeah. Thanks for checking in. I'm glad I can count on you, especially for Jacob.
Is that milk again? Fermented milk or something?
No, you're thinking of Yakult.
Right.
Yeah.
What are you
thinking? Which is
thinking of?
delicious. I don't know.
All right. So apologies for the for the blurriness, but you get the picture. So landscape company. That makes sense. Very good.
This was way too wet. I jumped the gun.
You always do that.
You know.
Okay. So this is a unit conversion question. Alan, if you can tell me what exactly, where you hit the roadblock, if you just had no idea where to start, because I'm happy to start in the direction that you started, because there are a couple ways to do this. There's some things you could reason out. There's just the normal, I always think stoichiometry, unit conversion stuff. What do you call it? Just unit conversion?
Yeah, stoichiometry specifically for chemistry.
Yeah, okay.
Yeah.
I like chemistry. I don't like chemistry. I hated chemistry.
Really?
Yeah. Okay, so I'm going to start with the very, very straightforward, this is how you do it every single time, unit conversion thing. Brady's going to be showing you something that's super helpful. Are you just... shouldn't it be yards? You think your stream is delayed.
This.
Got it.
Start with this.
Very possibly. Okay, so we have $30. And I'm going to put the dollars over here as units to the right because that's kind of normally how we write all other units. Why do we put dollars first? I don't know. It's not. I mean, I guess you know, but it's just stupid. Anyway, $30 per cubic yard. So I'm going to put cubic yards on the bottom. For every cubic yard, you pay $30. All right? Now, we need to multiply this by the right thing. This is going to have to be, and there are a couple ways to go about this. You can just know that 1 cubic yard is 27 cubic feet. Or you can say, well, I mean, literally have yards times yards times yards. So you could do, if you're really into this, you could do 3 feet over 1 yard. And then do that 3 times. 1 yard over 3 feet. And do that 3 times. Your yards would cancel. That's the whole point of this unit conversion stuff. Yeah, you might be delayed, Alan. I'm not sure why that would be. Maybe try refreshing. You could cross out those. Then you have cubic 3. Then you're dividing by 3, dividing by 3, dividing by 3. And now we need to get to 54 cubic feet. So now we have cubic feet on the bottom. 54 of these things. So times, and we can put it over 154 cubic feet over 1 because we're just seeing how many of those, how much money will it cost for all of those. So now these cubic feet cancel with the 3 of them down here. So we have 30. Now we just have money or dollars, whatever. So we have 30 times 54 over 3 times 3 times 3, which will be $60.
So that's
this is a unit conversion way. Do you want to explain that?
I do. Yeah.
Cool. Okay.
Alan, it's definitely the converting between cubic yards and cubic feet that probably got you here. Because you might think if 1 yard is 3 feet, then 1 cubic yard is 3 cubic feet, but that's not how volume works. right here I have a foot by a foot, which is 1 foot squared. Over here I have a yard by a yard, which is 1 yard squared. But if you think about how many feet squared would go into this yard squared, every yard is 3 feet. So this is 1 foot, 1 foot, 1 foot. So really what you have here is 3 feet times 3 feet, which means we're going to get 9 square yards. Sorry, 9 square feet in a square yard. And this is only area. I haven't even started yet with volume, but you can probably see where this is going to go. A cubic yard is 3 feet by 3 feet by 3 feet, which means that is going to give you 27 cubic feet. Nice little cube here. There we go. Very good. Some perspective. 3 feet, which is 1 yard. 3 feet. 3 feet. You're going to have 27 cubic feet in that, which is why Levi multiplied by 1 over 3 times, because that's going to be 3 times 3 times 3 is 27. This is a different approach, but that is how you would convert. So it's not always going to be 1 to 3. If you're going into multiple dimensions, it's going to be squared or cubed or things like that. Okay?
Yeah. This is what you definitely need to you have to understand this to be able to convert yards to feet.
You have to.
Or if you're just like a crazy analytical type of person and you don't care about this at all, you could feasibly just be okay with it saying 1 yard equals 3 feet over there, and then you know your units are cubed. But that's really hard. I think it's better to understand that 1 yard is 3 feet. Be careful when you get into different dimensions. The second dimension, you will have to square your scale factor, being 3 in this case, or 1/3 depending on your direction. But ends up being the same thing. Okay, happy to do more of your questions if you've got more. We're about to find out if you do. I'm also happy in the... Yeah, so this is all you got so far. If you have more questions, please let us know. Otherwise, we will just go back to robots' questions. Robot the dancer. Yes?
I need your help.
What do you need my help with, Bird? Oh. Hello there. It's Rob. Or
That's our
sorry.
friendly roommate.
Hey everyone.
He's so friendly. I was wondering who that was. Okay. So, yeah, we're going to hop back to robots' questions. What are you doing?
It's not for
Oh
you.
my goodness. How would I solve the triangle problem with similar triangles? Is that one of... Oh, there we go. Great. Awesome. We have another Alan question. Oh, this is a nice big question. Is that everything? No. There we go. Let's do that. Okay, so we got this triangle ABC, and then it has some other triangles put in it. This is a very common question to see, very common setup. In the figures above, triangle ABC and triangle BCD are right triangles as shown, so that's good. And then AD is 8, BD is 6, good to know. That's also given in the figure, it's drawn on there. And now the question is, what is the length of DC? Okay, I think I'm just going to draw my own triangle here. So I'm going to do that real quick. So I know I can do geometric mean to solve this. Geometric mean. Okay, but get confused on setting it up. Do you want to do geometric mean? Do you want to do geometric mean for this one? Are you looking at this or no?
Geometric mean?
Yeah.
Like geometric mean.
Yeah, I actually don't know what you're referring to, honestly. I don't know how that applies. So angle BDC is 90 degrees, but therefore so is angle BDA.
Yeah,
So just have them both on there.
I don't know what geometric mean. I know that there's like a theorem you can use for this situation. But I've never heard geometric mean. Maybe that's the name for it. Either
Yes,
way,
similar triangle solution. Great. Yes, that is what we're going to do for sure.
I would trust in Levi.
Yes. Trust in me. You thought about it. You thought about it, Bird. Okay. These three triangles that are here are similar triangles. You can just take that to the bank with you. If the big one is a right triangle and then you have an altitude from that right angle to the other side, all of the triangles are similar. I can also prove it to you. This is 90 degrees. So let's take the big one here. That has a right angle and it has angle A here. This triangle here, ABD, also has a right angle and shares this angle A. Therefore, by angle-angle theorem, we know that those two triangles are similar. Then we have this guy, BDC. That has a right angle and shares angle C with the big triangle. Therefore, those by angle-angle are also similar. If one triangle is similar to another, which is similar to another, they're all similar to each other, just with different scale factors. So we need to figure out what DC is. That's what we're looking for. What is this length here? Okay. Well, we're probably going to have to use that smallest triangle because that gives us the full length. Or we can use the biggest triangle, which now I'm thinking might be a good idea. Let's see what we can do with the smaller triangle, though. So we have triangle. I'm going to draw this down here. We have here, I'm just going to pull it out. We have BDC, and this is a right angle here. And then we have this other triangle, ABD. And I'm going to, no, I'll leave it here. So that's a right angle there, and this is the smaller angle up here, A, B, D, like that. So this angle goes with this angle, and then these two angles are congruent as well. Yes. Okay, we know this is 6. We know this is 6. We know this is 8. And we don't know what this is. This is what we're trying to find, so let's call it x, right? It looks to me like because these are similar, we now have enough to make a proportion and solve for x. So we're going to have 6 to 6, and now these 6's don't correspond to each other because this is the short side of B, or this is the short side of this big triangle, and this is the short side of the small one. So we're going to have, let's say, I want to do it with the little guy on top, it's a little easier. So x over 6 equals 6 over 8. You can cross multiply. I don't like cross multiplying. I'm just going to multiply by 6 on both sides. Another new, cool. Okay, and then these go away and you get x equals, oh, yes, good. Yeah, you must be on a delay because I don't think you saw anything groundbreaking with me pulling the 6 over to the other side. But I'm glad you see something. Okay, so this will be, let's simplify that. It's 3 and 4, so you get 18 over 4, which is 4.5. So x is 4.5. And that is the value, or DC, this equals the measure, or sorry, that's not for this. DC is 4.5. Okay. Do you have any follow-up questions on this? Just so you know, you can take it to the bank with you. That situation over there is always going to yield 3 similar triangles. If it helps you to visualize, you can pull them apart. The only thing with pulling them apart is that, you know, say you find another measure of a side length and you say, okay, I'm going to put that in this triangle. You might not realize that it's going to be one of the side lengths of another triangle, whereas if they're all here, they're all just labeled immediately. But this might be easier to see if you blow them up. This type of thing is also like the situation where you might have triangles like this and you have parallel lines, right? If these lines are parallel here, all these triangles that are nested within each other are similar because they all share this big angle here, and then by corresponding angle theorem with parallel lines cut by a transversal, these other angles are congruent to each other. Or, you know, these 3 are congruent, these 3 are congruent, so you have nested triangles that are similar. Be careful. This one you have to be very, very careful because you're not comparing this side to this side to this side. It's not what's happening. Makes sense. I was accidentally setting up 6 over 6 instead of x over 6. Good. Yeah, so you have to remember what corresponding sides are what. If you want, it might help to rotate this 90 degrees clockwise so that you can... Is that clockwise for you? Yes. 90 degrees clockwise because then you have the actual orientation the same and consistent throughout, you can do that as well. Remember, just let me finish up on this, and then Alan, if you have more questions, just keep asking them, because we will keep answering them. In this, remember that you're not comparing these, or you're not having corresponding sides between this side, and this side. It's going to be this little side versus this middling side versus the whole side. That is the correspondence there, because it's not just this piece. This piece is not a side length of any of those triangles. It's a piece of the side length of the big one. So keep that in mind. So let me just show you real quick. Let's just deal with half. So just one of these guys. To show you what I mean, if this is a length of 4 and then this whole side length is x, that's great. You have 4 over x. If this is y, it's going to be 4 over 4 plus y. That would be the ratio there. So just keep that in mind. If that didn't make sense, please let me know, and then we'll go over it. But because you're on a delay, Alan, anything you say, make sure you give it context, because I've probably forgotten what I said a minute ago already. Okay, let's see. What else you got for us, Alan? Anything? Not yet. That is fine. But keep the questions coming. Yeah, Bird, that's good. Let me get a problem. Yeah, go get it. Okay, Bird, you want to do Alan's next problem, or you?
Yes.
Okay, so then that's not happening yet, so I can just do a robot dancer question in the interim.
Just stall.
I'm stalling. Okay. Get out of here. This looks too involved. I don't want to do this. I want to do something quick so we can get through it. Maybe this one? This looks fun. Is there a question going with this one? No. Okay, cool. So let's do this one. So we want to get to there eventually. Great. And the directive is which expression is equivalent? So are these two equivalent? Often, what you can do on these questions, fastest way to solve... okay, sorry. Are you talking about your problem? Yes, you are talking about your problem. Okay, we will do your problem. Bird, you're up.
Yes.
Yep. No, that's not what I wanted. Okay, there you go. The question is, what is the fastest way to solve this problem?
The answer is don't get up as fast as I just got up, because then you'll get lightheaded. What are the two solutions to the equations above? Ah, all right. Here's the fastest way to solve this problem. Okay, no, here they are. Here they are. You're going to want to get everything over the same denominator. And by everything, I mean, let's just start with the left side. So 5 over x plus 3, the common denominator here would be x. You have to multiply 3 by x over x to turn it into this. 5 over x plus 3x over x. Okay? Now it's over the same denominator, so we could add them. I'm going to keep this right now as 4 over x minus 1. Okay? And then you can add these, which I will do. So we have 5 plus 3x over x is equal to 4 over x minus 1. From here, I would cross multiply. Now, you can always throw answers in and see if they work. So, like, you got 1, positive 1, negative 1, and negative 1. Throw those in. You know, you'll just, by figuring out if one of those works, you'll know to eliminate the other two. So very quickly, if I did this in my head, if I put 1 in, I have 5 over 1, which is 5 plus 3. The left side's 8. Then I have 4 over 1 minus 1, which is 0. Can't do that. 1 is out. It's got to be negative 1. So now I know it's going to be C or D. 5/3 or 3/5. I'm going to try here. Let's go with 3/5. So 5 over 3/5 would be 25 over 3 plus 3. We're getting into fraction land right now. I've already narrowed it down, so like I would say the fastest way, But doing this, probably not. It's really trying your answers out. So I'm going to try 3/5 now. 5 over 3/5 plus 3 is equal to 4 over 3/5 minus 1. If you have your calculator on you, then these will go a lot faster. But we have 5 over 3/5, which is going to be 25 over 3 plus 3 is equal to 4 over, this is going to be 2/5. So this would be 9. So we would have 34 over 3 is equal to, that'd be 4 times 5 over 2, so that's 20 over 2, which is 10. Not the same thing. Therefore, it is not 3/5. By process of elimination, it's got to be 5/3. I assume that's going to be right, because it's not positive 1, it's got to be negative 1, and it's not 3/5. We just proved that. So if this is a fair question, which they all should be, it's going to have to be D. That would be the fastest way.
Are you sure? I'm just checking, like, maybe we could do this super quick by actually solving. So you multiply the left side by x minus 1.
Well, that's what I was doing here.
Oh, that's what this is?
Yeah.
And how'd it go?
While I was in the middle of that, I realized it's going to turn quadratic. You're going to have to solve that, but you can put the answers in very quickly. Putting 1 in here is super easy. You're going to figure out that positive 1 doesn't work right off the bat.
Yeah, fraction land's fun. Stay away from decimal land. Decimal land is a terrible place. It's hard to do stuff.
At this point, you would cross multiply. 4x is equal to... So you're going to have to FOIL and then solve a quadratic, which is going to take some time. Which you can do, but faster would be using just using your answers. If you know how to plug a fraction into your calculator and store that for x, then trying out 3/5, you're not going to have to do all of this stuff here. Well, hold on. By the way, that goes right there. You could just sort it as x and then use x and plug that in. You'll see if both sides are the same thing. Oh, a little sine wave. Yeah. Okay. I'll erase this now.
You don't have that. That's not necessary.
What, that?
Yeah.
It is. This wouldn't have been enough juice. Trust me, I already did the numbers.
You ran the numbers?
Yeah, I ran the numbers.
Oh, okay. All right, Alan, you want to go back to that nasty problem? That's some fraction land stuff. Let's do some fraction land stuff. Bam, 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 bam. But also come up with more of your own problems. That's cool too. Okay.
In the meantime, we probably should talk about alta ipsum.
Talk about
Alta ipsum. Hold on, I gotta wait for it to come up. Doesn't have a point.
This thing that we're about to talk about, you can use it on your phone if it's smart. You can use it on your computer if it's a smart computer. If you're a person.
There it is. There it is. Yeah, computer, phone. It's an executive functioning app. Levi, what's executive functioning?
Executive functioning is what makes you a CEO of your own little company that includes you and your new secretary, Alta Ipsum.
Yeah.
It will track your grades. It will track your scores. It will track your grading scores. It will track your scoring grades. It will track when you have stuff due when you tell it. And then it will also set up these study schedules for you, these writing schedules, which is cool. Good, you'll have more tomorrow. Have more.
It'll plan coffee dates with your very important clients.
Like your grandmother.
Anyway, it's free for the first month. School's not in session right now, so it might not be what you need right now. But when school starts, this thing puts all of it into the app. I mean, you put all of it into the app. The app just tells you, "Hey, study Spanish for 20 minutes right now," and then you do it. You just listen to the app.
This is super hard.
The app?
This question.
Oh.
Actually, the app is probably pretty soft, seeing as it's software, Brady.
Oh.
What do you say? Why is it? Oh.
Those denominators are gonna. Something nice was gonna happen there.
Yeah, I know. It's pretty exciting.
Yeah.
You don't really need these parentheses, but whatever. So yeah, it's that big top guy over this big bottom guy, 25b minus 40 over b plus 2. Okay. Now, this is a factoring question, okay? And it's going to end up being here, but I'm not going to use this one. That is something you can do. Just like the last problem where Brady just chose a value of x, we could choose values of b, plug them in, and see if they work. We just got to make sure, as it says over there,
Uh-oh. I'm
There
going
he
to
is.
guess this is, am I right, Fatimata? Is that who this is?
Or Fatimad? I feel like
that's who this is. Your answer is right here, where he always is. I'm always right here. Where are you? That's the real question.
inside your computer.
Inside the computer.
Okay, so this is division of fractions, so I'm going to do keep, change, flip, because when you divide by a fraction, yay, that's nice.
That was my midriff. I shouldn't have shown my midriff. Hello.
You can never show your midriff, Bird.
I know. Oh, there he is. Oh, there, you're behind the white box. You're behind the white box. There he is. That's our roommate. His name is Rob.
Okay.
She's home. That's good. That sounds like a good place for you to be. Hey, how was your day? This is Levi.
I'm Levi.
This is the one who you asked about.
And yes, I am.
Yes, he is. And he's doing some vectoring stuff.
Doing some factoring
But
stuff.
I'm gonna be right over here.
So you can know he's there. So you have 8 plus 5b, 8 minus 5b, and then that's going to be over b times 2 plus b. And then we're dividing by this fraction, which means we have to multiply by the reciprocal. So that's what we're going to do. Multiply by, now b plus 2 is on top, and 5 times 5b minus 8 is on the bottom. So 5b, did I screw that up? Maybe.
Did a negative one.
No, I don't want to. 8 minus 5b, 5b, yeah, so I got to take out a negative 1. I should have taken out a negative 5 here. Okay, we'll get to that in a second, actually. No, we'll get to it right now. Okay, so here's the thing. We have a b plus 2, we have a 2 plus b, so I'm going to get rid of those two. That's nice and easy. And then we notice that we have a 5b minus 8, and then we have an 8 minus 5b here. Those aren't quite the same thing. You can't just cancel those out. So these two are going to be a bit of a problem. They're opposites. 8 minus 5b, if you multiply this by negative 1, you get negative 8 plus 5b, which is the same thing as 5b minus 8. So one of these has to be negativized, which means we're going to pull out, I'm going to pull out a negative from this one. So this will become negative 5 times 8 minus 5b. Brady, do you want to come up here and help me for a sec?
Yes.
Okay. So now we're here. Please let me know if this doesn't make sense, because this is a weird thing that you don't see, and you don't absolutely have to know how to do it. But this will get you your answer eventually, because look at the answer choice there. It has a negative. That's where it comes from. So this 8 minus 5b will now, so this doesn't matter anymore. This one, 8 minus 5b, will cancel out with this 8 minus 5b. So now we're going to be left with, we have an 8 plus 5b left over on top, so that's what we'll put on top, 8 plus 5b. And then on the bottom, we have a b and we have a 5, so that'll be 5b. And we have a negative on the bottom, which I'll just put out front. And there we go. A would have been the right answer.
Very good.
This is a hard question. There are multiple things that you have to know how to do, which is recognize that you have a difference of 2 squares, which is hard when it's 64 and 25b squared. And then you have to recognize you can factor this. You have to recognize you can factor this. Then you have to do keep, change, flip, because you're dividing by a fraction. Then you have to recognize that to get these two to cancel out, you have to pull out a -1. That's all very hard. I think most likely the easiest way to do this problem, especially if you have all 4 answers there, if you just have 1, you're going to put A, so you're going to get it right. So that's awesome. You don't have to do anything. I assume you're going to have 4 answer choices. Plug in values of B. You have variables in the question. You have variables in the answer. For any of these expressions to be equivalent, they have to be equivalent for any value of B you have aside from B is greater than 2. So why don't you plug in B is 3? Now that's going to be hard. So ideally just do this. It's going to be a hard question, regardless. If that wasn't, go ahead.
No, I don't want to.
Oh shoot! Oh, you. No, I'm actually done.
You're done.
You broke it.
I broke all of it.
You broke her.
Does anyone want help with their homework that I might have assigned them that's due tomorrow?
Brady.
What? That's
Brady.
That's what I was hoping. Now I can teach them during the day and at night. I can teach them all day.
And yeah.
And at night. SpongeBob. I don't know why the SpongeBob references are always lost on you.
Yes.
Yes, they are. But if you're understanding everything, then you don't need help. You're just checking in to see if I'm okay. And the answer to that is yes. I'm doing fine. I'm doing just fine.
Do they also write into you at school or no?
Yeah.
They
No,
also
the class is
comment
silent.
on Twitch.
The class is silent.
Yeah.
So I pass around a clipboard if they want to chat.
That's good.
Yeah. It's very good. It's extremely good.
Math is meant to be seen, not heard.
Yes.
Alan, we got a he, which could be referencing something yesterday.
He. You throw a she in there.
She.
Or he, she, he.
Or her.
Depends if it's the object or the subject.
Yeah.
Yeah. Any other questions? We're here for you, not for us. We don't want to do this. Our hands are tied.
We are your legal property for the next 10 minutes.
Yes, we belong to you.
Legally.
Very good. Very good. Are there more robot questions?
There are so many robot questions.
Are there more robot questions?
For those of you who might be confused, robot is an actual person. It's just their username. So it's not like we have a robot asking us questions.
Yes.
I just realized
Robot Dancer might be a robot, though.
That's valid.
We don't know.
Yes.
Yeah. What's the number? Robot Dancer or something? 67?
I have no idea.
Yeah, I don't know.
Do you know?
No, do you?
No, I was asking you, do you?
Very good.
Okay.
That's exactly right.
Wow, that was productive, our conversation. You want a hard one?
Yeah, give me a hard one.
But this just looks hard because there's a lot of words.
What if it's too easy? Can you explain? Oh, no. Can you explain unit circle again? Yes. Yes. Specifically which part? What it is, what all the different angles are?
I think she's asking what it isn't.
Oh, okay, so like a couch? Unit circle is definitely not a couch. We've already narrowed it down a little bit.
Would it be
a triangle? Fred triangle? You know what the fact of the day was today?
No. Is this Fred? Does Fred have...
Fred Triangle's father worked in a steel mill until it closed in 1986.
Oh, that's so boring.
That's Fred Triangle's life. What do
Boring?
you want? Okay,
It's very two-dimensional life.
I'll just jump into the unit circle then, okay? Again, if there are specific things about the unit circle that you're not sure about, is it the angles of the unit circle? Is it you just want me to just label all the coordinates and all the points? Where do they come from? Because if I'm just gonna go for it, you know what? This is gonna be a challenge. I'm gonna like this. Oh. All right, here we go. All right, we got that. 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 Okay, so we have
3 calls from robocallers in the last hour.
How do you know it's not Robot Dancer?
Because they're all my area code and first 3 digits.
I got the phone call that I had earlier during the stream was a robot caller.
Yeah?
You know, like they can actually fix that, but they don't. Being like our government. Like there's things that they could do that they're not doing. All right, so we have pi over 6. This is pi over 4. This is pi over 3. I'm going to use, actually, let's use some colors here. Pi over 2. Pi. This is 3 pi over 2. This is 0, but it's also 2 pi. Okay, so now we have 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. We have pi over 4, 2 pi over 4. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and now 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and 11 pi over 6. These are all the reference angles on the unit circle. I forgot this one. This is 5 pi over 6. In radians, all right? The whole circle is 360 degrees. It is also 2 pi radians, its angle measure, okay? Levi's going to draw some coordinates.
Who?
Sorry, never mind.
I was just going to make this nice and big so it's a little visual, and then you could do it here. And
Very good. Go ahead.
Is that what you want?
Yeah, no, do it, yeah.
Okay. This is not true. That's pi over 6.
Okay. Okay, so the coordinates of that would be...
Do you want coordinates on here or no?
I'm going to throw them over here.
Okay.
Yeah. Actually, it might be better to put them on there and then just talk about how they transfer over. Yeah, go ahead and do that. So over what I've drawn is a circle that has a radius of 1 on the xy coordinate plane, and I'm labeling the important angles in terms of radians, okay? So these important angles are all based off of the 30, 60, 90 triangle or 45, 45, 90 triangle. This right here is 30 degrees, 45, we have 60, we have 90, we have 120, we have 135, we have 150, we have 180, we have 210, 225, 240, 270, we have 270 plus 30, 300, 315, 330, and then 360, okay? But those are all in terms of radians. The concept of radians, do those confuse you at all? Do you understand why we have 2 pi radians in a full circle? Do you understand why these angles are all what they are? And then we could talk about coordinates. So what the unit circle tells us is sines and cosines of various angles. So pi over 6 is 30 degrees, but pi over 6 is the angle in radians. And this right here, this line represents the sine of that, and this line here from here to here represents the cosine of our theta. So there's our theta right there. So the coordinates of this point, because the x value is going to be this x distance, the x value is the cosine of the angle, and the y value is the sine. So the cosine of pi over 6 is root 3 over 2. The sine of pi over 6 is 1/2, okay? And if we just think about the 30, 60, 90 triangle that we created, this right here is 30, this right here is 60. The one thing we know is the hypotenuse is 1, because all the right triangles on the unit circle have a radius of 1, so the hypotenuse is always going to be 1. And according to our 30, 60, 90 pattern, which looks like this, that's our parent triangle. This right here has been scaled down by a factor of 1/2. Because on our parent triangle, we see 2 on the hypotenuse, and now it's 1. So everything is going to be divided by 2. So this is going to be 1/2 right here. This is going to be root 3 over 2, which is why we get those as the coordinates. Okay? So I would love to get some input from you. What is not making sense? What do you want to go into more detail about? What has your afternoon been like since class? Other questions. How does this turn into sine and cosine, the graphs that we know them as they go up and down? I'm going to need some more input. You go ahead and think on that. Once you know these basic points here, these coordinates, all of the other reference angles are built off of them. So 2 pi over 3 is directly opposite pi over 3. It's just across. That's not the best pi over 3 I've written. There we go.
Afternoon's been great, Bird.
Good. That's fantastic. So I take that to mean that there's nothing in particular you want to go into here. And if there is, you should tell me. And there's Rob again. Rob just keeps showing up. Rob, every time you show up, they lose a couple IQ points.
It's true.
Oh, man.
We've tested it. We run the numbers.
Yep.
Yeah.
Very,
Nah, we're just
heavily
kidding.
documented.
No.
We're just kidding. We're just kidding. No. Okay. Good. Well, that's the unit circle because I understand. Yes! That is what I'm going for. I'm going for that understanding. Good. All right. Yeah, that's the unit circle right there. So, like, yeah, because this is directly across the y-axis, it has the same height as pi over 3. Pi over 3's height is root 3 over 2. So this is also going to have a y value of root 3 over 2, but it is now the negative x value. So instead of 1/2, it's going to be negative 1/2. This right here, negative 1/2, but the same y value. Which means that 2 pi over 3 has a cosine of negative 1/2 and a sine of root 3 over 2. If you're having trouble, I mean, I don't think you are, but if you're having trouble remembering all of the intermediate values here, all of the like root stuff and all that, there's really 3 values. There's root 3 over 2, root 2 over 2, and then there's 1/2. I did not draw that out that well. But the fun part is, and this is something that I learned recently, they're all kind of in this pattern. Root 3 over 2, root 2 over 2, root 1 over 2. But the fact is, root 1 over 2, square root of 1 is just 1. So it's just, that's why we get 1/2 there. But root 3 over 2, root 2 over 2, root 1 over 2, which is 1/2. Yeah. All right, I think she understands.
I would say so.
Yeah, it seems like it. We're getting a lot of great input saying that she understands.
Wow.
Namely that, because I understand.
Yeah.
Message. Yeah.
You're a very perceptive teacher.
It's, I don't know. What do you want me to say?
I just want you to take it. Just take it and go,
But I try to be humble.
humble.
Very good. Very good. Is there anything else that you'd like me to talk about?
Fatima?
No, Fatimata. Yeah.
Oh, Fatimata.
Yeah.
Okay. Fatimata, I had a teacher with your name once. She taught me French. She was lovely.
There's also a 2, 3, 4, 5, 7 pattern. Oh, go on.
2, 3, 5, 7.
2, 3, 4, 5, 7, not 4. 2, 3, 5, 7. Explain. Are you talking about Pythagorean triplets? 3, 4, 5, 5, 12, 13?
No.
8, 15, 17,
That's
9,
not what
40,
she's
41?
talking about.
Do you know what she's talking about?
Yeah. There's also a pattern. 2, 3, 4, 5, 7 pattern, not 4. I thought you were a perceptive tutor.
That's very helpful.
I know.
Wait, you got to give us more than that. I'm not sure I understand. I'm trying my best.
Stop it.
What? I really am. That's why I'm sweating so much. Stop. What is this? Now I'm curious about this pattern. I want to know more. In the unit circle. 2, 3, 4, 5, 7. Do you mean with the angles? Oh. 5, 2, 3. So we have pi over 6. Okay,
7.
2 pi over 3. 5 pi over 2 pi.
0
Pi
pi
over
over
2.
6 pi over 4 pi over 3 pi over 2 2 pi over 3 3 pi over 4
Oh my gosh, 5 pi over 6.
6 and pi.
6, 4, 3, 2, 3, 4, 6. 2 in the middle. We got 3s, we got 4s, we got 6s. I did not know that. And then the other side, real quick. So that's
7 pi over 6, yeah.
This marker's not doing great. Yeah, we already did 2 pi over 3, so that's 4 pi over 3, 3 pi over 2, 5 pi over 3. Gotta take this marker out.
What is it now? Where are we?
We're at 8 pi. Sorry, 7 pi over 4. And then we have 11 pi over 6.
pi, yeah.
And then 2 pi. All right. We have 6, 4, 3, 2, 3, 4, 6. Wouldn't you know it? We also have 7, 5, 4, 3, 5, 7, 11. Which is something, but the denominators. You're absolutely right. Denominators have this cool little pattern here because of the way that we're adding fractions. Because there's always these simplifications that we can make. I never thought of it that way. You get 1 bonus point, and you can spend that 1 bonus point at the Brady store.
You can buy a Bradius.
You could buy a Bradius.
Or a Bradian.
Or a Bradian. I prefer Bradians to Bradiuses.
Yeah.
Or Brady-I, actually. But yeah, cash in the Brady point, the Brady store. There's lots of cool things. You got bouncy balls, you got erasers, you got pencils.
All right.
you
Have
got
a good night, everybody. We will
jacks.
see you
Wait, hold on.
tomorrow.
Is that time?
Yeah.
It is. All right. It's past 7:33. Oh man, we usually end at 7:30.
Equals negative b
Plus or minus the square root of b.